Hi everyone, let's take a look at the following functions. Y equals to x to the power of sine x, and we're looking for dy by dx, which means the derivative of y with respect to x. Step number one, when you think about the exponent, again, the common mistake is students are using the power rule instead of logging or taking the ln of both sides. So again, the mistake is one student would write down dy by dx, which equals to, they bring sine x to the front, they copy x to the power of sine x minus 1. And again, unfortunately, this is not how you do it. So what is the correct first step? Again, just like adding, subtracting, multiplying, and dividing, when you take the ln of both sides, it's the same idea. So ln is an operator, and you're operating onto y on the left-hand side, and you're operating onto x to the power of sine x on the right-hand side. Step two. One of the properties of ln is you can bring the exponent to the front. So sine x times ln x is going to be the following step. Again, exponent brought to the front. Now to be clear, I'm putting brackets around them. And now we're ready to find the derivative. We're applying implicit differentiation. And again, when you take the derivative of ln y, that's going to be 1 divided by y times dy by dx. On the right, we're applying the product rule. There are 5 steps. Step 1, differentiate the first. So the derivative of sine x is going to be cosine x times, you copy the second, which is ln x, plus copy the first one, which is sine x, times the derivative of the second function. So the derivative of ln x is going to be 1 divided by x. Now, dy by dx equals to, the opposite of dividing by y is to multiply by y. So on the right, it's going to be y times cosine x times ln x plus sine x divided by x. Now, the goal is to express the final answer in terms of x. If you go back and you look at the basic function, y equals to x to the power of sine x times cosine x times ln x plus sine x divided by x. And again, if you want to factor 1 divided by x to the front, another final answer could be dy by dx, which equals to x to the power of sine x minus 1. So notice what I'm doing here. I'm dividing by x. So when I take sine x, or x to the power of sine x divided by x to the power of 1, I'm dividing with the same base. So I can subtract exponents. Again, in the brackets, this is going to be x cosine x ln x plus sine x. Again, both answers I think are acceptable. It really depends on your teacher and the textbook and the course pack. Now, here's the second case. Y equals to sine x to the power of x. I would like you to try this. And of course, when you press pause and you go through all the steps and you press play again, I'll be here. Welcome back. Here's the first step. Again, when you think about y equal to sine x to the power of x, the first step is again to ln each side. If you think about the properties of ln, one of them states that the exponent can be brought to the front. So x times ln of sine x. Again, the exponent brought to the front. We're now ready to find dy by dx, and again, we're applying implicit differentiation. So when you take the derivative of ln y, that's going to be 1 divided by y times dy by dx. On the right, you're applying the product rule. Take the derivative of x, that's going to be 1, copy the second part, ln of sine x, plus copy the first part, which is x, times the derivative of sine x, or ln of sine x. So that's going to be 1 divided by sine x. Again, don't forget the chain rule. You have to multiply by the derivative of sine x. That's going to be cosine x. Now, when you isolate for dy by dx, you can multiply both sides by y times, open bracket, ln of sine x plus x times cosine x all over sine x. Now again, your final answer should be in terms of x. So one final answer is going to be dy by dx equals to sine x in brackets to the power of x times ln of sine x plus x cosine x divided by sine x, or dy by dx equals to sine x to the power of x times ln of sine x plus x times, now cosine divided by sine, or I should say cosine x divided by sine x, is also known as cotangent x. So again, follow your teacher's instruction, the textbook, the course pack. You can do it if you believe you can, and I hope this makes sense.